In this video, we will go over how we can use packet capture via the FortiGate CLI. So we need to specify the interface. So if we use any like we are in this example, then regardless of which interface packets come in from or go out, it will be visible in the output. Alternatively, we identify the exact interface to dial in on that specific interface only. Next, we specify the filter, or essentially the criteria that we are looking for in a packet to be able to show it in our output here. Then we have the verbosity. Typically, you're only going to be using the number 4 or the number 6 here. If it's 4, think of it like this. One line of output is going to show per packet, whereas if we use 6, then the data contained in that individual packet will show as well. So it's going to show a lot more information if we use the number 6. Then we have our count. So if we specify 0, then output will continue to show on the screen that matches the filter until we type in Control-C on our machine. If we put in any other number, let's say we put in number 10 here instead of 0, then 10 packets that match that filter need to be matched, and then at that point the packet capture output stops. And then lastly here, this is an L for Lima. It's just going to be displaying the timestamp along with our packet capture. All right, so using the topology that I'm showing here, as you can see, the interfaces, they're highlighted in orange there. Let's just use this topology and go through some examples now. All right, so with this command here, what we'll be looking for is we're going to be trying to match for both ICMP and the following host 4.2.2.2. So both conditions have to be met, and then we should have some output here. So I'm just going to send a ping from the client machine now. There we go. So we see the traffic came in from 192.168.112.2 to 4.2.2.2. Then we can see the source NAT from the WAN 1 side of things. And then the response from 4.2.2.2, it comes in on the WAN 1 interface for the echo reply, and then that gets again forwarded back to the source machine. So that's just one successful ping happening. Okay, so now another example here. Let's say we're trying to match traffic that might go to 8.8.4.4, or it might go to 1.2.3.4. So we want to match any of those two conditions. Well, let's start the capture here. And then now let's ping 8.8.4.4. There we go. We have one match that's showing up there. And then now let's have another ping that goes to 1.2.3.4. Okay, and there we have it, right? So we can see the first one, 8.8.4.4. We see, just like the other example, is that the ping request and reply was successful. But then interesting here is that 1.2.3.4, currently whoever owns that IP, it doesn't actually respond to that ping request. But as we can see here is the packet did come in to the internal interface of the FortiGate. It was forwarded out the WAN 1 interface to the ISP. But then, obviously in this case, we didn't get a response back, and therefore we have no echo reply packets that are showing up as coming back in. Okay, and now this example, how it differs from the first couple examples is that now instead of us just going diag sniffer packet any, we're going diag sniffer packet internal, and we're actually identifying the name of an interface that we want to focus on, and then we have our filter as usual and a couple of these extra switches at the very end there. So let's run that command. We'll send the ping out to 4.2.2.2. We're just going to send out one ping. There we go. Okay, so in this case we can see since we're focusing on only the perspective of internal, we only see two lines of output here, and again that's expected. So the packet came in to internal, and then it obviously went to WAN 1. We can't actually see that in this output expectedly. And then the return packet, we're seeing it from the perspective of internal as well, and we can see that echo reply comes in based off of that echo request. So in this next example, let's assume that we know the port range that could be used to match a certain destination port or source port, but we don't know exactly which one it is so that we can identify the traffic. Well, we can actually specify the port range in a filter. So if we specify this port range, now let me just send some packets to 1.2.3.4, and then let's use port 27005, which is within that range. And there we go. We can at least pick up on that based on this filter. Okay, and let's use another use case. Let's say we're trying to filter for traffic that might be matching a specific range of IPs or a subnet. We can identify that as well by using the net filter option, right? So in this case, based on this filter, even though it's 177.177.177.0/24, well, if I send a ping to the IP 177.177.177.100, it's still going to get picked up by that filter. All right, so in this case, let's say we're trying to match traffic that would be arriving from a certain MAC address, but we don't actually know which traffic we're trying to match specifically yet. So in that case, what we can do, looking at this Windows machine, here's the MAC address. So just using this, specifying the interface and going ether host and then the MAC address, we can filter for that specific MAC address. So now let's just send a ping. Sorry, before we do that, let's actually start our command. And, there we go. Yeah, right away, we're just seeing traffic that's coming in from this machine that I'm currently on right now. Now, just one thing to be careful there is that if we are going to be using that command to identify the MAC address or filter based on the MAC address, just make sure that there's no layer 3 device between the FortiGate and the source device. Otherwise, then that command is not going to actually work. You would have to be putting in that layer 3 router's MAC address instead. Okay, so in this example, we're pretty much just going to be showing what happens if we have a filter and then we actually specify, instead of 0 for this option here, we specify 6, right? So once I run this command, as you'll see, after 6 packets have been seen by the filter, immediately the sniffer command stops. Okay, we have a last example here. So in this example, we're going to be focusing on just the WAN 1 interface on the FortiGate. We're going to be looking for traffic that's ICMP and destined or from 8.8.4.4. And then we're using number 6 here. Number 6 here means pretty much show me the payload of the traffic, and just give me more details about the packet. And then yeah, let's try it out now. So I'm going to send a ping here. It'll be 8.8.4.4. Awesome. Okay, so here's some interesting information. So we see the echo request, and then we see the successful echo reply, and it's all from the perspective of the WAN 1 interface. So on the very first packet, here we go, we see this is going to be the destination MAC address. So this would essentially be the ISP's MAC address. This is the MAC address of the FortiGate's WAN 1 interface. And then we see the same thing, but in reverse on the return packet. So that could give us a bit of information to be able to identify what the next hop device is that we're communicating with. Maybe we're working with the ISP and we need to give them some extra information, but pretty valuable there. And then we can even see on the right side there, we can see the actual payload of the packets. You'll see obviously a bit more information if the traffic is not encrypted, like in this case, it's just an ICMP, but overall just gives you a little bit more visibility if you're looking for something specific within the packets. All right, so that wraps up this tutorial. Thanks for watching, and we'll see you in the next video.